Nesta que é a última edição do Periférico do ano, estivemos à conversa com o Michael Pound, investigador e professor na Universidade de Nottingham, no Reino Unido, bem como convidado frequente no canal do YouTube Computerphile. A nossa conversa incidiu principalmente sobre a sua especialidade, que é reconhecimento de imagem e visão por computador. Espero que gostem. Já agora, este episódio é em inglês.
One thing that while I was preparing a bit for the interview, that I was wondering is you did a bachelor's in science in computer vision in 2003. You started in 2003, right?
Yeah.
So that's about the year we were born.
Yeah.
So it's a bit weird to
Thanks
think
for telling me that.
No, it's just a note because for us, at least for me, computer vision, I know it's not recent. I know it's something that has been existing for a lot of time, but I was wondering how different is it now to compared to when you started studying it, what were the major changes? What were the things that you studied, and how did they impact later on, and how do they impact now?
Yeah, it's totally different. So there was machine learning, but there was not sophisticated machine learning that solved many problems, right? We were in a kind of lull where machine learning existed, but it wasn't particularly useful for lots and lots of different tasks, certainly not like it is today. So the image processing we used to do with computer vision would be very low level pixel stuff. So we're sort of looking for small areas of color of a certain shape or certain features that we can kind of lock onto. And a lot of that was kind of hand designed and programmed. So you would spend a lot of time writing stuff that walked over pixels and did, different operators and things on that. And nothing worked very well, right? The accuracy you might expect, you'd be pleased with 60%, right? It was not good. And you would spend 4 months developing a method and then another 2 months just fixing like one edge case that didn't work because of the problem was hard. Now it's much more of a data problem. So now it's much more about, well, we've got this data set. How can I create a network that learns on that data? And the edge cases are dealt with automatically by the learning process. And so it's much more of a data analysis, experimental design question than it is necessarily about low-level image stuff. However, I think it's still really useful to know that stuff, right? Because I think, you're not going to get that far in computer vision if you don't understand what a pixel is or what what RGB is and what the relevance of it is. And sometimes you still see some work that uses low level filters and things like this, right, as part of pipelines, bigger pipelines. So there are uses for these things, but I think I just like to understand how things work. So I like to know all that stuff. But if I did my degree now, I might not know it so well because I haven't had to do it for years before, I mean, deep learning only really took off in 2014, 2015, realistically. And so I had quite a few years before deep learning where I had to just do it by hand, So, yeah, it was quite different. There also weren't very many libraries. So now you install a library to do some task. If you're writing a website, you install React or something like this, and it produces this lovely web interface for you. Well, you didn't do any of that. You basically had to program it all by hand, which meant that all our websites looked terrible and took ages to develop. But it also meant that we were quite experienced at doing low-level stuff. So, it's different.
Yeah, that makes sense. Like, at least one thing I noticed while having this computer vision class, most of the time we would just import a Python library and it would do stuff for us. So that makes sense that at least back then going low level is more important now, maybe, to a lot of decisions. But other than that, then after your bachelor's, we were wondering, we assumed that you did a master's, a thesis. What were these on about? What did you did your thesis on? We tried to look for it, but couldn't manage to find. But we were wondering.
It's not worth reading. I didn't do a master's. because I skipped straight to a PhD. That was more possible back then, only because there were fewer applicants and I was graduating with a good degree, and the school was happy for me to stay on. It is still possible to do a PhD without a master's. It's just another part of a CV that we consider. So I did my undergraduate dissertation so that would have been about 2006. I did that on jigsaw solving, would you believe? So I basically had this idea that I wanted to take a picture of a load of jigsaw pieces and solve the jigsaw. And again, without machine learning, that is unbelievably faffy and hard to do, because you have to basically separate all the jigsaw pieces, and then you have to go around all the little edges of all the pieces and work out whether they're an in bit or an out bit, and what color they are and all this kind of stuff. And I think my best was like I solved like a 5-piece jigsaw or something. It's really rubbish. But huge amount of code just to get to that point. So not a useful tool in any sense, right? But it was interesting, and it taught me a lot about how images work. When I got to my PhD, I worked on object tracking. So object tracking is the idea of following things around in a video. And again, it was quite different back then because computers weren't very fast and we didn't have deep learning. So you had to make a lot of trade-offs of accuracy and speed, right? If you want to look in an image for a person that you've seen before, you haven't got the computational power to look all over the image, because there's no speed for that. So you have to basically predict where the object's going to go and look in that area, and then you maybe have some backup plans. You look over here just in case, kind of stuff. But you have to. So a lot of it was to do with where you look and trying to be a bit smarter about how you predict where objects are going to go. But of course, after my dissertation, I went and worked in a different lab and stopped doing that, and I haven't done any tracking since then, right? So in some sense, it was a good training for me, but that's not an area I work in anymore.
That makes sense.
I meant to ask, just going back, or not really going back too much, but about like how your field and many fields now are going really deep into AI in the sense of machine learning. Do you feel we might be DFSing into AI too much? Like we're sort of only exploring this approach, but also I think this might come off as a bit sort of ignorant about the whole field, because there might be a lot of techniques I'm just not aware of. But it feels sometimes as though, due to some social and economic implications besides the techniques, that we're going too deep into AI, or like sort of forgot that there's a lot more stuff around we could be exploring.
I think, yeah. Oh, sorry, I kicked my camera cable. Let's see if I can. There we go.
Yeah.
Sorry, my USB camera is plugged in where my feet are, and I get all fidgety. Yeah, so that's a really good question. I think the answer is both yes and no. I think that AI has huge implications for a lot of fields, and it is going to be very useful. Ultimately, the reason we are all using AI now is because it is working better than the image processing we used before. Right? Because ultimately, it's easier in 2025 to produce a data set and train a network than it is to design an algorithm to do the same task. The challenge, I think, is just determining the cases where AI is a hindrance rather than a help. So I'll give you an example. Some of the researchers at Nottingham, and indeed at lots of universities, work on a problem of scheduling, right, which is a problem of fitting certain timescales together, and some of them work with Heathrow, right? So Heathrow Airport is one of the busiest airports in the world. They have to send planes out every 5 minutes, and scheduling those planes is difficult. AI will not help with that problem. It will make it worse, because AI is usually random in its effort. We can't guarantee that it will work, right? 99.9% accurate means that every 100 times or every 1,000 times you're going to get a failure, which we do not want. So optimization is a completely different branch that will use AI sometimes, but won't most of the time, and rightly so, because we need actually verifiable solutions to some of these problems. So I think the interesting thing will be in the cases where we sit somewhere between the two. So, for example, medical imaging is a case where AI could help, but you also want verifiable solutions, right? You don't want some AI saying, no, you're fine, off you go, and it turns out that is not the case. And so I think that there are going to be times where AI is definitely the right thing to do. Face recognition, right? There are times where AI is probably okay, but we have to be careful, like medical imaging. And then there are times where we shouldn't be bothering with AI at all, or we should find a way to develop a new kind of AI that isn't, but not like what we have now, right? Which could work in these areas. So I think people need to be a bit smarter about what they're doing, and they need to not assume because AI is exciting and everyone's talking about it that's obviously the answer for everything, because that doesn't really make sense. Yeah.
You talked about scheduling, which is kind of funny because here at Cesium we're currently working with our course director to basically help them out with scheduling and all of that. And at least for us, AI was never seemed like sort of the solution. We tried to also we're trying to do basically a solver to fit all the students, more in the area of I'm not remembering the name in English.
Integer programming.
Yeah.
Yeah.
More in that area, we're trying to go that way instead of using stuff like AI. It's kind of funny.
If you just give a list of student names to a large language model and ask it to schedule them, it will get it completely wrong.
Yeah.
Right? It won't schedule them. It will probably make up some names and remove some other names. Right? It's not what that kind of model is for.
What I would assume. Sorry.
Yeah. So I think people need to think more carefully before they just assume that's the right thing to do. So I think you're using the right technique.
What I would assume would work in such a case is like using AI techniques for like finding heuristics, maybe that might be.
Yeah. So I guess we should probably distinguish between the AI that I tend to work with, which is like the vision language models, and other branches of AI like heuristics and things like this, which are very reasonable, right? So, there are methods of solving problems using intelligent algorithms that are not quite the same as kind of this flashy AI that everyone talks about, which is, of course, not actually that helpful in some of these cases.
Of course. Also, one thing that is of interest here in this sort of field of conversation, since you do like vision specifically, and also I assume you know a bunch about like image generation.
Yep.
I meant to ask, what do you think about using AI to detect AI? Because it sounds a bit strange, but also like I can't quite tell from my lack of experience if that's a really good idea, or if AI is going to be as meh as it is with other stuff at detecting AI.
I think it's a tool that you could use, but the idea that you could have an AI that would be 100% foolproof is ludicrous. Right? So, one of the things that I've been looking at recently is this idea of security around large language models and making sure that they don't, for example, leak data and stuff like this, which is extremely hard to do because they leak data all the time. And one option is to take any input to the large language model and pass it through a different large language model, which looks for malicious prompts, right? And then when the output comes, pass it through another large language model, which looks for malicious output. Now, both of those things are not perfect, but having to launch an attack across 3 large language models, all trained to do different things, is so much harder than just tricking one, right? And so it's about, I think, damage limitation and lowering your attacker's options rather than assuming you've completely sealed the problem off. Right? So I think that you have to be careful with your designs for these things.
I'm not sure if I got my point across, but what I meant to ask is like for like video and an image specifically.
Okay, so for video and image, you could train an AI to detect those things, and it will work fairly well on the data set you train it on. But I don't see that as a long-term solution, because a different image generator might have a different kind of image which fools it, right? It's quite easy to, once the system exists, you can train a model to circumvent it, right? So you will end up in, what we would call an arms race, where, you're trying to train a new model to detect, and then the image generator gets better and you do this, and you're not actually solving the problem. So I guess I got a bit distracted talking about large language models, but I think the same thing applies for image generation, which is that you have to bury these tools in layers of other tools that help detect these problems. Some of them could be AI. Unlikely, I think, for all of them to be AI, because I think that's not going to work long term. And the other thing is that image generators are getting much better all the time. So, anything that works now is unlikely to work in a year's time, and definitely won't work in 5 years' time. And so we need a better solution than that, right?
I have a question. It's a question and a proposal of a potential solution that I don't know if you might have thought of. But since you teach security, you know about both of these topics that are involved in said question. But essentially, do you foresee a way where we can sort of verify or like sign images and videos as being like made with an AI-free source? So like from cameras, it might be not too hard. Like we might be able to just say, look, this video was recorded by such and such at such and such, and we encrypt, sign, and all that. But for edited videos, that might be a more concerning.
For edited videos,
problem.
I think it's So I think you're right that cryptography is probably the solution that people need to link together with. Like, no one doing AI very few people doing AI are also doing cryptography, and vice versa, right? And so I only happen to know because I teach cryptography. But if you digitally sign the output of your camera, it's going to be much harder to fake that image, right? Similarly, the AI generating models could digitally sign their output, right? Now that would involve all of these companies getting on board and doing that, which I think is unlikely.
Yeah.
But you could imagine that there might be an artistic merit in having a camera that signs its output in a way where we have some idea of the provenance of the image. The problem is that, like you say, people are editing their images and editing their videos, right? And so actually most professional photographers won't just ship the image with no changes. And that becomes a bit more difficult because it's not clear how we solve that problem. I think you would need to have cryptography embedded in every process. So, your Adobe Photoshop would also have to say these were the steps that were made, and so on and so forth. But Adobe Photoshop has introduced AI, right? And so, where does it end, right? So I think that what we may have to do is focus on the really important cases, right? So CCTV camera, likely that needs to be signed, because if it's not, how do we know that's a real CCTV is not that good quality anyway, right? It's going to be very easy for AI to generate fake videos of people doing things in CCTV, going to get people in a lot of trouble. So we need some way of saying this is or is not a real video. But I think we have to prepare for a time where it isn't possible based on the image data alone, and you need some kind of system around it, right? Certainly I would assume that, because it seems unwise to assume that we'll always be able to detect it from the pixels.
One thing me and Carlos were talking before the interview was basically there's been a lot of growing of crawlers that gather data from different points. And one thing we were talking was how some artists are already doing stuff like poisoning, in a way, their data. I was wondering if you know about this and how it could basically help secure these types of informations and training of models. Because one prominent problem, at least I've been hearing in recent years, is how basically companies don't want to stop using crawlers to gather data, and how artists are trying to reclaim their copyrights on their own data.
there's loads of different techniques that have been invented to try and defeat crawlers and defeat image scraping. Nightshade or variants of it are one of them, which are these image poisoning. And what they do is they basically adapt the image in a subtle way so that the large language model misreads what it is, right? And that means that it's difficult to train on that kind of image because the image is basically trying to train it in the wrong direction. And I mean, you can probably detect that nightshade has been added to an image, which means that they might not use it in the training data. But of course, that's entirely the point. Either they use it in the training data and it makes their performance worse, or they don't use it because it's poisoned and you don't have them training on your copyrighted data. That actually seems kind of reasonable. My personal opinion is why should someone have to give their images over to an AI company, right? That doesn't make sense. I don't think you should be compelled to do so. Another thing people have done, which I think is quite interesting, is that if developed websites specifically to get crawlers stuck. So infinite file systems where it just goes into a website and it has a load of links, which it goes to, which have a load of links and another load of links, and none of the data on there is of any value at all, which I think is quite funny. So people are annoyed about it. Ultimately, probably the solution is government regulation rather than people taking it into their own hands, right? We need to decide as a society whether it's okay to scrape all the images that are on the internet. And if it's not, we need to restrict it, right? If we decide it's okay, then fine, we'll do it. So I think that, that's probably the decision. Unfortunately, you also have other governments who have opinions, right? So it's probably quite good for the United States government to allow it because that's where all tech companies are and they're bringing in lots of tax revenue. So, well, some. So the, other countries might have a disagreement over what's acceptable and what's not.
Yeah, that makes sense. Like the disagreement, previous disagreements on UA regulation compared to the USA, that makes a lot of sense.
Yeah. Well, I had a question that's like way less deep and interesting, but you might know a lot more about this than we do, and it sort of might have something to do with poison pilling, in the sense that it fools AI, or maybe it doesn't anymore. But reCAPTCHA, did you know how that works?
Do you mean the little grid thingy?
Yeah.
It's a huge data scraping exercise, as far as I can understand. So what they developed was a way of getting humans to annotate images, right? While also letting them go through, and so what you do is you have some images that are kind of roughly labeled. And then over time, you can build up incredibly detailed segmentation masks of things by asking who's in what. What I don't know is the accuracy of the model that checks you're working, right? Do they care if you don't select the correct stairs and things? I'd imagine they allow a certain amount of error. But CAPTCHA started as a very simple mechanism of like a difficult to read text, right? Now, actually, those things have sort of been defeated because CNNs can read those texts now, usually. The new reCAPTCHA tool was developed, I think, primarily as it was a slightly harder problem, but it was also a problem where the output of a user clicks is also interesting, because you've just told it where all the stuff is, and that can be used to train a model, right? The ultimate will be when they do things like which of these two paragraphs reads more nicely, and you can do kind of large language model feedback as well. But we haven't done that yet. But no, it's a very simple process. They just take a random image from their data set, they chunk it up, and they probably have some idea based on their own existing models where certain elements are. And then they will use the human feedback to correct those models and get better over time.
Well, wait, let me think. Like how do I segue this into anything else? sort of a non-segue, but I guess I wanted to we wanted to speak to you about like your work with phenotyping and the stuff you've done there, because I think you've been doing that for like quite a long time, and you've done like a lot of it, both for like recognition and generation. How does like that come about? Like how does a proposal to like do biology stuff come about to a PhD?
Well, my work started on phenotyping in 2011, 2012, something like that. And it was because a bigger project was funded by the UK government with biologists and computer scientists on board. And I was one of the computer scientists employed to do some work on that. So I was more junior at that time. So I was what we call a postdoc. So I was someone who had a PhD, but wasn't an academic. Since then, because I've become interested in that as a problem domain, it's quite easy to find collaborations because there are lots of people who have lots of data that they don't know how to analyze, and I have the ability to do that, and so it kind of makes sense. But also, I'm trained as an interdisciplinary researcher, so I'm quite used to talking to people from other fields who I don't understand all the time, and vice versa. And that kind of language barrier, for want of a better phrase, takes a little bit of time to learn your way around, right? Biologists go about experimentation and writing of papers, for example, in a completely different way to computer scientists, which is not worse or better, it's just different. And you have to learn all those things as well. So it's taken quite some years to do this, but you kind of get used to it. But these days, what usually happens is maybe the UK government puts out a call for funding of, let's say, AI for biosciences, right? Which is basically means we don't really care what the AI is. It has to contribute towards biological sciences. And it's then up to the researchers to decide what an interesting idea would be, put it forward, and then the panel decides whether it is indeed sufficiently interesting. And so I happen to know a lot of bioscientists because I've worked with them many times before. And so at that time, what we would usually do is have a conversation about what kind of things they're working on, what kind of things I'm working on, how they might align together. And then we have some ideas, and we sort of write this proposal of what we would do if we had, let's say, 2 or 3 years funding to do this. And then we submit that proposal and we see how it goes. But if you're proposing to do bioscience research, it usually has to be driven by some kind of biological question. It's not sufficient to say, I'm going to do AI and I'm going to run it on plants. Usually you have to say, and we're going to get this specific outcome on wheat where we grow better, taller wheat or something like that, right? You can't usually just do AI. It has to have some tangible biological benefit, right? It's the same as medical imaging, right? It's exactly the equivalent. In medical imaging, it isn't sufficient just to say I'm going to image medical stuff. There has to be some kind of clinical advantage to doing this, right? You know, is a doctor going to benefit or a patient going to benefit from what you're doing? Those kind of links, you have to try and argue why you're doing what you're doing and what the benefit will be.
I was also wondering, like, what are what is a phenotyping specifically?
Yeah.
And what you've done about it, and like what's that been sort of more technically?
Yeah. So phenotyping is measuring plants, right? You can also phenotype animals as well, but it's the phenotype. If you remember your back to your whatever your equivalent of A levels is, school age stuff. A phenotype is the kind of physical outcome of genetics usually, and your environment, and so a taller plant might be taller because it's received more water, or it might be taller because it's genetically different to another plant, right? And the phenotype is the height of the plant. And just knowing how tall a plant is not interesting, right? Because we can all see how tall it is. What's interesting is whether if we can determine that some food that we gave it, or some some ploughing that we did on the field, or the lack of weeds, or the introduction of insects, or some other or genetic changes, right? Some tangible change that someone made has caused that outcome. And that's then interesting because you can say, well, we want taller plants for this reason. Let's breed specific plants that do that thing, right? And so on. So phenotyping is in some sense the measurement that goes alongside biological exploration and experimentation. So, you're trying to grow better crops, right? That's what you want to do. We want to measure the crops to see which ones are doing the best and see if we can work out why and how we can make all the crops do that well. Phenotyping is the measurement stage in some sense. And so what in practice that means is things like measuring number of leaves, the size of the grains, the depth of the root system. It can depend, on we might phenotype disease. So this plant exhibits more disease than this plant, right? And so from a sort of computer vision point of view, that means measuring stuff in images, right? Which is helpful because that's mostly what I do. But it can apply equally well in plants or humans or medical, or, it doesn't really matter to me. The images are all just image data, but it's similar kinds of tasks. And so you could imagine it goes all the way from kind of microscopy all the way up to sort of field level measurements with drones, right? And everything in between. But it is always about measuring stuff.
Yeah. One thing that I was wondering was basically, Carlos talked about generation. Then I'd assume at least you talked about drones as well. Stuff like LiDAR and stuff like that are normally used for projects like that. How hard, or at least what's the most difficult details in a way of reconstructing these digitally, in a sense to explore them, one just to make some sort of sense out of it. Basically, in a project I've seen, they talked about using LiDAR to basically map out forests and trees, for example, in tree generation algorithms as well, and stuff like that. But how difficult having at least the knowledge behind computer vision, and what kind of different things have you worked on in generating those kinds of plans and stuff like that?
So LiDAR is commonly used in forests because forests are often, but not always, fairly sparse, right? You just have trees sitting in a row. You do your laser scanning and you get a good distribution of points around the trunk of a tree, and you can start fitting cylinders and make models and things like this. Smaller plants are much, much worse because they're very dense. And so let's imagine you go into a wheat field, right? And you have a plant, maybe a few inches from the next plant, and they're all very dense. So, they're going like this and then they're kind of overlapping. If you run laser scanning in that field, you will see maybe 3 or 4 inches into the plant, and then you'll get nothing back after that. So you can't see anything else. And that might be okay. Maybe you only care about the top bit, but it's not practical at that kind of scale. The other problem is that you just get a load of point data. So you just get a huge point cloud of data of like, this is where there was a surface, this is where there was a surface, and you haven't measured anything, right? You need to actually then go and measure those things, because the biologist doesn't want to know that there was 1 million points. They want to know that the general height of the plants is this, and the average angle of the leaf is this. And so you have to go and find those leaves. So it's a lot of the problem we have is that collecting the points or collecting the images is kind of somewhat easy. But turning that into something that we can understand is much, much more difficult. And that's also the problem with forests, right? So forests, you'll go in, you'll collect these LiDARs, but you've still got to then find where all the trees are and fit models to them and stuff like this. So there are a few approaches that people use. One is I guess what we used to call them, I don't know whether people still call them this because deep learning took over, right? But we used to separate between top-down and bottom-up approaches. So a bottom-up approach is where you take the points and you start connecting them together and you slowly build up an idea of what's going on. So from the bottom, right? Top-down would be you have a model of a plant and you try and fit it to the points. So you already know the shape of a plant and you're kind of going from a top, and you see what I mean? So you start with the model and you work downwards. And both of those you still see use, right? So people are still doing segmentation of point clouds, but they're also doing model generation of plants informed by point clouds, right? And both of those are options. Which you do will depend on the lab, right? But I see good results from both. But neither of them work all the time. Right? Plants are difficult.
Makes sense.
I wanted to ask sort of like, what has been the most impactful thing you've done, or like, if you've ever seen your research and work being used sort of away from academia and in the world, and if you've seen it be impactful.
Yeah. So that's one of the nice things about academia, actually, is that you do have an impact. And so, for example, I've developed various tools for analysis of plant root systems, because people don't think about plant roots because they're underneath the ground, right? You don't need to worry about that. But actually, of course, the health of a root system is very, very directly linked to how good the plant is when it's droughted, or when there's extra water, or when it's trying to get nutrients. And so, because all the fertilizer that the farmer puts down is drawn up. It doesn't go in the leaves; it goes up through the roots, right? So, and I was lucky enough to work for quite a number of years with lots of people who were experts in root systems, right? The biologists. So I developed various tools to do various different kinds of analysis of root systems. So we're talking about segmentation of cells in microscopy, but also tracing along the root system in two-dimensional images and even three-dimensional CT scans and so on. And this stuff does get used, including in industry, right? So I meet people who have used my tools from all across the world, and you would think they wouldn't, right? Because it's just some little root analysis tool. Why would anyone use that? But ultimately, people are measuring roots, and it only matters to the people that are doing it. But of course, it has a knock-on effect that they produce better crops and so on. And some of our AI methods are being used in companies like big seed growers that produce the seeds that go in the ground that produce the good crops, right? And what I've learned is the amount of effort that goes into producing seeds is quite extraordinary. Right? You don't just take a decent wheat plant, get the wheat off it, and then sell it. Right? You breed thousands and tens of thousands of different genetic varieties, and you find the very best one every year. And you also have different ones targeting different kinds of soil and things like this. And some of my tools get used in processes like that to find those kind of plants. Right. So, I'm not going to oversell it, right? Plenty of other people do these things as well. So, that's good. But it is nice. It is nice when that happens. Often I don't hear about it because they're going off in industry and doing it quietly. But, occasionally I do.
One other thing that segues nicely with this, and that I meant to ask before the next part of the interview, is how has it been to be in academia? Because I'm researching right now, and I'm well aware that it's not quite the same as being a professor and being in academia for real. But I at least feel as though there's a good bit more freedom in terms of how you manage your time and stuff. And it feels like it could either be sometimes as stressful as industry, and even doing the course was at points, because like test rushes, grading and stuff like that doesn't seem too pleasant. But also it seems as though there's times in the year when there's a lot of time to explore stuff, sort of intellectually and academically. And as you said, you do see a real impact around the world from what you've done.
Yeah. So academia is very different to working in industry, but there are also some similarities. So I have friends that work in industry, and I know what they do, and they know what I do. And, they have the same kind of rough complaints that I have when things are a bit annoying and taking up too much time and too many meetings and so on, right? You can't escape those things, I'm afraid. There is more freedom, to an extent, right? I think this idea, but maybe academics can do whatever they want, isn't quite right, because, you know, it's the kind of American tenure track model, which is that once you've got tenure, you can just do anything and no one cares, right? That's not really the case, because if you do nothing, they're going to ask you to leave. So you know, you still got to deliver good stuff. You still got to write papers. You've got to do teaching. You've got to get money in and grant money and so on. But you have freedom to work on any area of that you want, as long as you're making an effort and being successful. So, for example, I do a lot of plant phenotyping, but more recently, I've also been doing medical imaging and other stuff because they interest me, and it's similar kinds of work that I'm an expert in. I didn't need to ask anyone permission to do that. I just went off and did it. And the university will be pleased that I'm doing extra stuff. So in some sense, I have a lot of freedom to work on something. And there's no one, I'm not trying to ship a product, right? So no one is saying, well, we need to deliver this by this deadline. I can do exactly what I want, right? But again, I can do what I want as long as it's something useful, right? If I'm doing nothing, then people will complain. So it can be both really good because I can do anything I want, and a bit daunting because you've just got this open book and you've got to put good stuff in it. And, you know, what is that, right? And some people are better at it than others. And you see these professors who are incredibly successful and everything they do is amazing, right? And then you see people who are in the middle, like me, who are doing fine. And people who are new who think, crikey, what am I going to do? And I guess you get used to it over time. But yeah, it's both good and bad. I would say it's mostly a positive. I wouldn't do it if I didn't want to, right? Because I could get a job in industry, right? I can code, and, you know, I'm not worried about that. I choose to do what I do because I enjoy it. And I love the teaching as well, by the way, because that's a different side of academia that you don't get in industry. But there are days when managing 5 projects at the same time, all of which are different and none of them are currently working, you know, it's difficult, right? So, you know, you have to take the good days and the bad days, I guess.
You talked about teaching, and about that in general. I guess in a way to connect. Basically, with this boom of AI, what would you consider is the best tip you can give to students who could be listening? Your students here at Umingo and other colleges, stuff like that. What would be probably the thing you consider is more important for them to know in this boom of AI?
I think that getting a handle on the way that you learn is the most important thing. So one of the things that concerns me about AI use is that, and I'm generally not concerned about AI use, right? Mostly I think it's fine. The issue is, for someone who cannot code at all, using an AI to do it for you is not going to teach you to code, right? Whereas if you know how to code, using an AI might make you faster or might make things a little bit less boring or what have you, right? So there's a time to use AI and there's a time to put in some hard work to learn something difficult, right? And I think there's a temptation, certainly in some undergraduates that I see, of their main goal is to pass the exams at the end, right? It doesn't matter how they get to that point. They just need to get there, right? And so they will use AI, they won't use AI, they'll sort of cram for the exams and not really take anything in. And then they'll get to the end and they'll pass the exams and then they'll forget everything. And then they have to go and work in software development and it's very difficult, right? Whereas the people who come in and they learn about computer science, and maybe sometimes they use AI to help them, and maybe sometimes they do it themselves, but they get to the end and they understand the work and then they do well in the exams because they understand the work, those people are going to do fantastically well in a job. So I would say that if you over rely on AI right at the beginning of your study, right, at the most formative, important time when you're learning the fundamentals of computer science, that's a risk, right, that you have to be careful. So by all means, talk to an AI, ask it questions, use it as essentially a fun Google search, right? But bear in mind that's what it is, and you're not implicitly learning that just by having it in front of you. You've got to do that hard work, and sometimes it is kind of hard work, which is a bit depressing, but that is unfortunately the way it works. On the other hand, in terms of just a different take as well. So in terms of what I think students should know about AI, one is don't over rely on it because it won't always be there, and you need to know how these things work, right? But on the other hand, if you want to learn about AI, it's a hugely fruitful thing to know about. But I would always focus first on the fundamentals of machine learning, right? So don't just assume that by running a large language model on Google Colab, you've kind of got this whole thing nailed and you can now go off and do AI, right? Those things are incredibly easy to do once you understand about machine learning. So I would always look at the fundamentals first. So if you're interested in AI, take a machine learning course and learn about the slightly less interesting random forests and support vector machines and learning rates and loss curves and things like this before you go, oh, no, I can do all this exciting retrieval augmented generation stuff, right? That's the next step. If you go too fast to the end, you will only have a superficial level of knowledge and you will end up getting overtaken by the technology, right? And we don't want that.
Yeah, they make sense, at least for us, at least. In our first years, AI wasn't as prominent as it is now, and I guess in a way it showed in some classes, but in other classes we've seen that AI, at least due to the crunch that we were talking about, sometimes we relied a bit more on it than we should. But in the end, we tried every time to understand the most out of the class and try not to go out of class without knowing anything.
Yeah, I don't know if in where you are, tech companies will interview you using programming assignments, right? So they'll give you programming interviews.
They do.
Right? If you have used AI for 3 years during your degree and so don't know how to code, those are going to be very, very difficult, right? Whereas if you struggled for 3 years, you're going to find them actually quite easy, right? The problems that they ask in these interviews are not particularly hard for someone who's been coding for 20 years. But the practice of thinking about them and stuff, that takes work. And so I suspect, I don't know for sure, right? Because there are some people who think AI is going to take over everyone's jobs, right? I don't really agree. But I suspect that companies are only going to be doing more testing because they want to be sure that someone works without the AI before they give them the AI. You see what I mean, right? If you have 2 software developers, one of whom requires AI to work and the other one doesn't, you're going to hire the one that doesn't, right? It's a much safer hire. So I think you want to be able to do both. Right?
Yeah, that makes sense.
Okay, now finally moving into like the lighthearted sort of half of the interview, like not half, just about 10 minutes, 15 maybe, not to take up too much of your time. I was trying to compile a couple of questions that might be short to answer, might work. One that I came across is like, what's like the tool with the goofiest name you've worked with? Like things that just sound weird. A couple of days ago, I came across a paper about lemonade, which is lemma as in like for proofs, and aid with that they use AI to try and speed up proofs. But yeah, lemonade is goofy
nice
name.
I always think that a lot of papers pick the name first and then do the research to fit the name. I read a lot of AI papers with really stupid names. One of them was really rude. Like it was like I can't remember if it was something like tits, which is obviously an English word for something else. And I was reviewing this paper and I said, look, you can't call your paper that, right? Even if the acronym is correct, even if it's like transform or something. It's like, no. Like, please rename it. And I think actually we have to be a little bit serious that we don't want to completely make the whole of academia just about silly names, right? The other one I used a lot. So there's a very, very popular tool in bioscience communities called Fiji, right? Which is which is so basically there's this tool called ImageJ, which is a Java-based image processing tool. It's very good for low-level stuff. And someone released a sort of derivative of ImageJ called Fiji, which is Fiji is just ImageJ. And just the name is so confusing because the name is like a loop to itself, and also it's got nothing to do with the country Fiji.
It's just to GNU.
Yeah, it's just very odd. So anyway, the tool's great. The name is weird.
What else?
You had that one if you want to go for it. Basically, we were talking yesterday, and we were like wondering when your friends call or maybe just check up on you, is it a mic check?
I haven't had that many jokes about my first name. I have had quite a lot of jokes about my surname, because it has so many meanings in the UK. So obviously it's the main currency of the UK, and so I used to get a lot of comments like, Mike Pound and his Uncle Euro, and stuff like that. And it's like, yeah, that's maybe funny the first time, Mike, but I've heard this now 200 times. I'm fine, thank you. And jokes around how I'm going to have to change my name if the UK adopts the European currency and so on and so forth, right? So all that kind of stuff. Luckily I've and also of course lots of jokes in the YouTube comments about me pounding information into people's heads and things like that, right? So another play on my name. I don't mind those comments too much. They're quite funny.
One thing I was wondering when I was driving over. So pound is both the currency and the weight measure. But why is like the symbol for pound an LB?
You mean, yeah, this... Oh, yeah, I mean, I have absolutely no idea. and we're like the Americans. We have really weird units of measure where we use some of the old ones and we use some of the new ones. So, for example, if I stepped on a weighing scale, I would weigh myself in stone and pounds because I always have, right? But if I weigh anything to go in a recipe, I would weigh it in grams and kilograms, right? Which makes no sense at all. But that's just how we do it here.
But at least you guys in the UK use the metric system. Or...
Mostly.
Oh, okay.
Yes.
Okay.
Yeah.
Apart from for milk, which we do in pints.
Oh, okay.
And beer, of course, beer in pints. Yeah, it's weird. I think what happened was in 1971 we decimalized everything and we made everything metric, but people didn't like it, and so they kind of clung on to some bits. We should just, because we drive in miles, right?
Oh, okay.
But we run in kilometers. If I go for a run, I would go for a 5 kilometer run. But if I get in my car, I will go for a 3-point-something mile drive.
Might be an ego thing. Because I ran 5 kilometers, not 5.
Yeah, it might be. Yep.
Yeah. One last note I had. This might be a bigger question than should for this time in the interview. But thoughts on AI slop content that's been flooding people's minds and feeds.
Basically brain rot. Yeah, I think you can call it that.
Did you see there was a study the other day where they had people write essays with AI and without AI, and they measured their brains?
Yeah.
And they found that basically the people using AI didn't really use their brain at all and didn't learn anything, right? Which is kind of goes back to my original point. I think we all kind of know that. AI should be used to shortcut things where that's appropriate. But you're right that what AI allows you to do very quickly is produce endless amounts of content of questionable value, right? Sometimes it's funny and sometimes it's useful, but I don't think everything we do has to be... I'm not one of these people who goes home and watches only intellectual documentaries, right? I watch sitcoms and boring things, right? And things that block my brain because I've done enough difficult work already that day, right? So I don't have a problem with people looking at slop in some sense, but we produce enough of that as humans, right? We don't need an additional load of AI to also do it. Some of the image generation is really funny and quite clever, and so I don't mind that. But I think that just generating images for the sake of it and putting them in everything is not really adding. And I think the same is true of writing, right? I mean, you know, you can see this when you do a Google search, right? You do a Google search and it AI's the bit at the top. And you read it and you're like, well, it's kind of helpful. I actually want to see the article because that's probably got the actual data in it. And I'm not sure I'm better off for having that there, if that makes sense. Yeah, I don't know. I think the other thing, it goes hand in hand with social media, right? So it isn't just about the content, it's also about the way in which it's presented, right? So, for example, TikTok, where everything is very short form videos and you're just scrolling and scrolling and scrolling, right? It's probably quite easy to argue that that's not good psychologically, right? It's quite addictive. It's not, you're not getting a good amount of information to people in that short period of time and so on. But there's not enough research on it yet, right? I mean, the research doesn't look good, but the research is not there. So I think in general, it's not just AI. We're producing too much nonsense, and sometimes it's funny, and sometimes it's just a bit of a complete waste of time. I don't have any answers for that.
Yeah, seems like a good point to sort of end the interview. Thank you very much for being available and coming. It's been a pleasure.
No problem at all.